Hello everyone and welcome back. So in this one we're going to build the simple scene in Houdini and render in Karma XPU. Hopefully it will be a beginner friendly tutorial as I'm going to do it step by step, and we will also touch in some intermediate topics like expressions and maybe some vex. And yeah, let's get started. So let's start by dropping a geometry container, and I need to import the logo, so I'm gonna use regions from image and leave all the default settings and paste, and I'm gonna paste the image path which I have in here, so something like this, and let's wait. So since this takes a little bit to load, I'm gonna probably cache it. I'm just gonna add this, add a custom attribute and say the black color will be logo so we can select it later. So let's just file cache and remove the time dependent cache, as we just want a single frame. Let's name it logo FC. Oops. And let's blast, and we will blast. Oops, do we have this? I forgot to add the name attribute. And now we can save and pick the logo, and we're going to delete all the attributes. So attribute delete, and we're gonna just say delete non-selected, which will delete everything. And now we will create the soap. So let's create a box. Let me adjust the UI, and we will say 0.7 in X, 0.16 in Y, and 0.4 in Z, and we will add some subdivisions like 6, 3, and 4, something like this to have it even. And now we're going to bevel it, and we don't want to bevel. If we bevel everything, if we just bevel, it will bevel everything, so we need to exclude the flat edges. So let's say 30, and for the size 0.029, and we will add some subdivisions, something like 3. And now we can place it with the logo. We can place the logo, we can place, so match size, we can place the logo on top of this soap. So let's do min and max, and we will also say scale to fit, and probably move it a bit down. Let's move it a bit down, minus 0.005, just a little bit, and I'm gonna transform it to scale it down, and I'm gonna scale it down by 0.75, but we want to do it in the center, so we will use the centroid expression, so 0.75, so it doesn't sink in. Now I'm gonna place a null so we can reference it later, and I'm gonna say it's font, and we're gonna extrude it. So I'm gonna extrude it by 0.02, 0.02, so this should be enough. And as you can see, we don't have the back faces, and as we want to intersect these two objects, so we will create a boolean. We will also mirror in the y-axis in this case, and here's the trick. We are mirroring from the world origin, so 0, 0, 0. That's why we don't have the objects connected. So for that we can say in the origin bbox 0 the y min. So we want to mirror at that the y min of the object, so the minimum bounding box. And now we can finally boolean it. So let's create a group, let's create a boolean, and we will say union and connect this and this. Do I want to... So here's the thing, we can create a boolean union in here, and this will totally be fine. As you can see, we can use this for final render, but I'm gonna go a step further and do some remeshing in this. So instead of boolean union, I'm gonna use a shatter mode, and as you can see, this creates these interior faces, so I'm gonna use surface in here, so we get just this logo stamped out. And I'm also going to subdivide in here, so I have more information for the remeshing algorithm. So I'm gonna subdivide it by 2, and I'm also going to create a group, a primitive group, and I'm gonna call it soap base. And now we're going to create a connectivity, and we want it on the primitive. So we have something like this. I'm gonna fuse it. And I'm gonna fuse by a smaller value, so it doesn't fuse very closed points. And I'm going also to triangulate and doing a quad remesher. You don't need to do this if you don't have it, but since I have it, I'm gonna do it. You can totally do a boolean union and do a small bevel afterwards, and it will be fine, but I'm gonna just show you another technique that I saw also on a quick tip from CG Wiki's Discord. So I'm gonna use 20,000 and use the class attribute, so it knows where to orient the polygons. So let's quad remesh it. You can use the trial version, by the way, that's what I'm using right now, but I'm gonna totally buy this because it's worth it. It's a really great plugin. So as you can see, we have the polygons oriented, and I'm gonna file cache it, so when you look at the file you don't have to have this plugin, you can just use the file cache. And from here I'm gonna import the font, so we have these. I'm gonna extrude it, extrude, and I'm gonna inset it by a little bit, since we want to do a group transfer, so I don't want to spill out too many outside faces when we do a group transfer. So I'm gonna remove output side and remesh it a little bit so we have some more subdivisions. So if we do 0.005 and do some smoothing iterations, and we can group these and do a group transfer. And I'm gonna remove this and transfer the group to. And you need to play a little bit with the values. I know a value of 0.0061, it will be just fine. As you can see, it's not working in here, so we might add a subdivision. So let's try to subdivide it. Since we did a remesh, we want to subdivide it with open subdiv loop, and let's say 2. Let's see if that fixes that issue, and it does, because we have some, as you can see, if we don't have this, it will not work properly, the group transfer, because we don't have enough geometry. So extrude, and we will extrude the group 2, and it's working fine. Let me just check something, and we will extrude by 0.03. So it's up to you how much you want to extrude. I'm just trying to match my reference. And we will also bevel it, and we will bevel it by, let's first exclude the flat edges. I know a value of 89 it will work just fine, and 0.001, as I don't want too much beveling, and let's say 3 divisions. So it's, as you can see, this is working much better to do the beveling with a proper topology, or a good enough topology, I should say. And as you can see, if we play with this value, it will pick some hard edges, so a value of 89, it will work just fine. So yeah, now we can just subdivide it. And let's subdivide it by 1 is fine. I guess this is okay. And let's create just an output node or a null and call it soap. So this is the first part done. So let's now create the bubbles and foam. So for that I'm going to scatter some points, but before that I'm going to create a density attribute with an attribute noise. And I'm going to say density and float, float. And let's say we use simplex element size, so how big the noise is, in this case 0.42, and I know an offset of 7.7 will give me a nice result. You can just play with this until you find where you want your bubbles. And I'm gonna scatter, and I'm going to scatter 400 points, so 400, and use the density attribute, but as you can see it's still placing points on on some parts I don't want, so I'm gonna remap this. So enable remap ramp, and let me see, I'm gonna push it quite a bit and push the reds, the high values, so something like this should do it. And let's see, our scatter is better, maybe we can push it a bit more. Something like this is fine. And I'm gonna play with the seeds and maybe remove the relax iterations. Let's see, yeah, let's maybe remove that. And I'm gonna do an attribute randomize, and I'm gonna say p-scale, and going to use the new feature, which is the remesh bubbles, to create some bubbles. So as you can see, this is way too much, it's way too big, so I'm gonna globally scale it to 0.07. And I want to control a bit more the size. I want to have some precision, let's say, on the size of the bubble, so I'm going to use a custom ramp. So custom ramp, and I'm gonna play with these values. Let me just set it to 1, and I'm gonna say I want some big bubbles, then some smaller ones, and maybe increase this one and this one. And I'm gonna totally play with the seed. Let's say we like this, maybe play with the seed here. So maybe we like this. Now you just need to find a good position. So let's keep it like this, we can change it later. So this is our bubbles, and now let's go in here and create the foam. So I'm gonna group the density, so points at density bigger than 0.1, and I'm also going to group expand it, like doing an attribute expand, so I'm using the group. So group 3, and I'm gonna expand it by 4, let's say. So I want to grow the foam a little bit, and now we can just blast, delete non-selected, and blast the group 3, and we can remove the visualization and delete any small parts. So let's go with a smaller, something like this. And I'm also going to pick it, because we will convert this to a VDB and it will go a bit outside the surface. So minus 0.01. This is not strictly necessary, but... And now I'm gonna create a VDB from polygons. But this is not a closed surface, so we will need to use another trick in here. So bear with me. So in the VDB from polygons, I'm gonna say this is density and 0.01, let's see. Okay, now create a VDB topology to SDF, and as you can see we get this thickened shape. We could just extrude it and do a VDB, but this will also work fine. So now we want to reshape it, so reshape SDF, and we will dilate it quite a bit, so by 5, so we have a thicker foam, and we will convert VDB, and we will convert this to let me see, we will convert this to a VDB, and VDB class we will convert SDF to fog. We don't see much, but we can create a volume visualization and play with the density scale. So this is our fog. Now we can just create a name in here because we will use that later. And now let's create a VDB from polygons, and we can just copy from here. And we will use instead a fog VDB and maybe fill the interior. And use this. 0.01 is fine, and in this case we want to actually increase the density, so we will use a volume wrangle, and oops, and we will say at density times 5. So in this case we will have actually some more density, and now we can create VDB combine, and we will do subtract. So we will do subtract. So we get something like this. Let me check here. Yeah. And let's create a volume visualization in here and increase it. So we get this result, which is fine. So this is for the foam, and we can create a null and call it out volume. But this fog or this foam will be just too uniform in this. In here we will have the bubbles, but will be too uniform in here. So let's create some noise, and we can actually do that pretty simple with volume noise fog. And we will create zero centered and high amplitude and an element size of 0.003. You can see this will simulate the smaller bubbles that we don't actually have, but just play with the offset. And this will be our volume. Now we will create a shape to hold our soap, so like a plate. I'm gonna call it like a plate. So I'm gonna start from the soap, create a null, and we will start with a box. and do a match size. Oops. Match size. And let's check our soap. Oops. Something like this. And we will scale to fit and remove uniform scale. And we will also give it some subdivisions, so 9, 2, and 6. And in the match size we also need, now this one is fine. Now we place it in the center, so another match size. And now comes the tricky part. We need to scale it while keeping it equidistant. I believe that's the word. So bear with me. We will, if we scale it like this, as you can see, the space between all sides is not the same, so we could eyeball it. So let's say we scale it by 1.26 and we can try to eyeball it, but I'm not very good at eyeballing it, so I'm gonna use instead an expression, and this will be quite a big expression. Maybe there are better ways of doing this, but the thing I'm going to do is calculate the size the ratio between the original size and the scaled size, so getting the difference and then adding it to the scale Z, in this case, as you can see by the gizmo. So I'm not very good at explaining it, but maybe you will get the idea. So expression, edit expression, since it's going to be a long one, and we're going to do bounding box. We will take the Z size, so the Z scale, and we will subtract again the bounding box size Z by the X size and multiply it by this channel. So I know that's channel scale X, and I'm gonna divide it by the bounding box, so I can just paste it by the bounding box that size. And as you can see, that is not yet working properly because we need to do some bracketing, so we will place one here and another one in here. So it's not working yet, so we need one here, bounding box that size minus bounding box X size multiplied by channel X 1, 2, 3 and divided by the Z size. So let me see why it's not working properly. So it's giving me 2 while it should give me 1.4. So in here it's actually X size. So now it should be working properly. As you can see, we have the same space between this size and this size. So again, we will use this expression another time, so it's good to have it working. So that was the way to scale it uniformly, or not uniformly, but keeping it equidistant. I believe that's the word. So now let's just clip this, but we will do all primitives, so clip it in the middle, and we will also create the groups so we can extract it later. And now we're going to do the same. We're going to scale down the bottom, so let's group the bottom primitives. So binormals 1, 0, and let's do -1. So we will group these bottom primitives, and let's again transform it, and we will transform the group 4, so group 4, and as you can see, if we transform it uniformly, we will have again the same issue. As you can see, it's not the same space, so we will do instead 0.9 in here and copy the same expression. So oops, Control C, Control V. So as you can see, now we have it working, which just makes me feel a bit less stressful, let's say, although it's always a pain to find the right expression, and ChatGPT can't really help you that much, at least with the prompts I entered, it didn't help me much. So let's say we want to bevel now this bottom, so 0.08, and let me see, oh, we need to blast, and we will blast the below, the top I mean, and now we can bevel it, and we will enter 6 divisions, so we have something like this. And let's group the unshared edges, and we want to extrude now these edges out, so let's try to extrude, and we will extrude the unshared, and as you can see, it's not working the way I want it, neither the options, so we will need to manipulate normals. So for that, let's create a normal, and I believe I need it on the points. As you can see, they are all pointing down in this edge, so we can use an attribute expression and flatten. So let's pick normal and flatten z explain, and now we have them straight. This is a nice trick, and now we can use existing normal, and we will extrude it by 0.084, and now we have the normals all messed up, so let's create a normal. Everything is working, and now we might want to bevel this edge in here, so let's create a bevel, and we will exclude the flat edges, and with a distance of 0.004 and 3 subdivisions. Now let's extrude this. So extrude by 0.0075, and as you can see it's extruding out. I want to extrude to the other side, so we can use a reverse in here and use the output back, and we can place another normal to fix that issue, and we can just subdivide, and we can subdivide 2 times maybe, and then just place a soft normals. That will fix our issue. So let's select this, press A and drag to smooth out the network. And now we will create we will align this shape. So let's go, let's first merge the incoming geometry. So let's create a name so we can target it in Solaris. So soap and bubbles, and we can merge. So like this, and then we can match, we can actually match size in here. And we will do max and min, and let's check this, and we will offset it 0.139. Oops, maybe not so much. Let's press Ctrl to actually see the shape. And let me check. We will need to play a little bit with it. Something like this will do fine. And let's create a name in here and call it plate. And now we can merge this name with this margin here. So something like this. Let's attribute delete, and we will just keep, let's delete non-selected, keep the normal and the name. So we have a name for each object, and also group delete to clean a bit the geometry, and let's delete everything. Maybe we need to play with these bubbles. I'm not too happy with that, but let's see. So create a null and create out soap Fight Club. Fight Club is a great movie. It's one of my favorites. So let's maybe do like this. And we have the volume, and we have the scene, and now we can move on to shading. Okay guys, let's move into Solaris. So before that we might want to do a file cache. So let's name it soap fc. Now let's save it, because sometimes it starts to calculate the network and it might cause some crashing and slowdown, so it's always a good idea. So let's press D, go. I don't want to see the environment light, and I need a dark background, and I want to render the viewport size. So let's SOP import, and let's pick out SOAP. So this, let's create and let's name it SOAP. Oops, what have I done? And let's duplicate it and call it foam and import the volume. So we should be having the volume. Let's create a material library and also a dome light. We will do some custom lighting, but for now let's use this one from Polyhaven. We can also create a camera, so something like this, and create a new camera, and Karma renders Karma. It will create the render ROP and the Karma render settings. So let's remove the visualization of the camera, and we can create a basic material, so Karma material builder, and let's decrease the diffuse and assign to all. I mean, we can remove the foam for now, and let's just see how this looks. So we actually need to change this to XPU, and I'm gonna change a few settings. So I'm going to the limits. You don't need to do actually this much, but I'm gonna increase it anyways. So I increase the refraction limit and set the volume to 16 and the SSS to 12, let's say, because we're going to use some subsurface scattering on the SOAP. So let's start by that. Let's start by creating the SOAP material. So let's create a Karma material builder, and I'm gonna say SOAP mats. Oops. Old habits from Maya. Always name it mat. We don't actually need it in here, but and I'm gonna change a few settings so we can leave the diffuse because we will use a full subsurface scattering. So roughness, I'm gonna change it to 0.37, and I'm also going to include some coat. And in the subsurface, I'm gonna use a custom color and just copy it to the radius. So copy and paste and increase the subsurface, and as the scale I'm gonna use 0.002. So let's autofill and go in here and pick the SOAP, and let's see how that looks. So it's a bit too reflective, but it matches a bit more my reference, so I'm gonna keep it like this, but feel free to introduce some roughness, a more rougher material. I might play with the coat roughness, so but yeah, I'm gonna keep it like this. And when we introduce some lights, it will create a more dramatic look. So yeah, that's our soap material done. Now let's create the material for the bubbles. So let's create another Karma material builder. We call it bubbles matte. And for this one is quite simple. We just need to increase the transmission to 1 and check thin walls. And we will also introduce some thin film. So let me just make sure we assign the material. So autofill and create a bubble and assign to the bubbles. Let's check. It's a bit hard to see, but again with the other lights it will look better. But you can see how this is looking. And let's now introduce some thin film. Let's say we want an index of refraction of 1.8 and a thickness of 200. We will start to see something, but I actually want to use a noise to have some more variation, so I'm gonna use a unified noise 3D and a frequency of 40 and let's say an offset of 30. That's the values I used before, but you feel free to use another ones. And I'm gonna also use a feet range. Oops, it's just range, not feet range. And I'm gonna use a thickness of between 50 and 250, and you can have a look at the noise. So if I unlit, if I show you how this looks, so this is how the noise looks. And if we connect this to the thin film thickness, we should be able to start to see some thin film. And if we don't see much, we can increase. As you can see now, it's more noticeable. Let's keep it to 1.9 for now, and we will see if we need more. So that's our bubbles done. Now let's create the material for the plate. So Karma material builder, plate matte. I'm saying plate, but I don't actually know the name for this, so forgive me for that. And I'm gonna say it's going to be a metal. And as the specular roughness, I'm gonna load a custom texture. So Karma triplanar. And let me see which texture I used. So C14. I'm gonna have to pick it. So I just pick my texture. I can show you how it looks. And lit material. There should be a way to debug the nodes, but the debug button doesn't actually work, and we need to assign this to the plate. And let's wait a little bit. So this is how it looks, and I'm actually going to increase the size and also increase the blending. As you can see, that helps with this edge. And let's introduce some random scale and play with the seeds, something like this. And now let's connect it. Let's create a separate color for, so we can extract just one channel. And let's use a mix. We can use the red channel, and we will say our roughness will vary between 0.4 and 0.23. Those were the values I liked. So specular roughness, and we will have this look. Let's maybe try to introduce now the lights. So let's focus on that next. Okay, so let's create a rectangle light, so light, an area light. So light 1, and I'm gonna pick a rectangle and look through selected and enable the lock, and I'm gonna place it so right here. So something like this. So let's check our lights. So we have a light there. Let's look through our camera and render with Karma XPU. Let's disable the dome light, and we will increase it to 4 and maybe 1. Maybe that's too much. So something like this. We have this nice lighting, and let's create another one. So or maybe I don't like the sharpness of the light, so I'm gonna introduce a texture. So I have here an HDR texture to use as a light. So as you can see, it gets darker, so we need to increase the exposure, something like this. It will just create a softer fall off, as you can see. And let's duplicate the light, and I'm gonna place it on the other side. So look through light, light 2, lock it, and let's place it in here, let's say, and let's look through our camera, and we will decrease the effect of these lights. So actually, let's see, let's increase it actually to 0.2, and let's enable the other light, and let's actually use a bit of the dome light, so set it to 0.3, and let's enable it, and of course it will compile again. So it's already looking much better, the lighting. So now we will introduce the foam. So let's enable it, and we will create a material for the foam. So let's see, Karma uniform volume material, and that's fine. And let's add it, and we will add it to the foam. Let's see if that works. So that's actually not working. Let me check. Karma material. Let's see. Enable smoke, scatter fire, binding density. Let's increase this. So it's not binding the material properly. So let's do the following. Let's cut it from here. And let's create another material library. Maybe we need to remove this one, this default material. So let's see now. Is it binding? It should be. Let me check. Okay, now it's working. We just needed to remove that particular material in there. So let's pick, let's check how this looks. And volumes don't work well with render regions. And one issue I was having when trying to render this scene was that I was getting some shadowing between the bubbles and the foam, and I don't actually want that. So let's do the following. Let's create a render geometry settings. And load the foam. Let's load the soap bubbles and the foam, and let's look at the final render. And in here we will pick shading, set or create, and remove the shadow contribution. So let's check again. And we might need to increase, let's see. Render region doesn't work well with volumes. So let's increase the density, so 150. We might need to play a bit. This is not looking. So this is okay, but maybe we need a bit more thickness on this volume. So let's go back to soaps and maybe let's see the results. So control click and look at the volume, F, and as you can see it's just not thick enough. Let's have a look in here. So yeah, it's just too thin. So in the VDB reshape, maybe we will decrease the group expand to 2. And we will increase the reshape to 12. Maybe not so much, maybe 9. And maybe increase the amount of bubbles, so say 600. And play with the seed. Let's say something like this. And I was calculating the volume anyways, so let's try this again. Maybe let's increase this 0.05. And maybe increase this one to 8. Let's try that. Oops, I need to save it. So the volume is fine, but in here I need to save to disk. And let's go again to Solaris. And this will not be the same as the final result I had because I tweak it quite a bit. But let's try to get something good. The tutorial is pretty much done, so if you want to skip this part, feel free. But let's just check now. Maybe we need to decrease now the... And maybe let's play a bit with the lighting. So let's decrease this to 4. Maybe not. And let me render and see the results. Let's maybe decrease the density of the volume, so let's go again to 100 because that's way too much, and now it's looking a bit better. Let's render it and I will be back in a second. So maybe the size of this fog volume is too much, this fog noise. So let's just quickly change that. So in here 0.025, and let's go back to the stage and do the rendering. So yeah guys, I ended up doing a full render with some more samples. As you can see, I increased it quite a bit and just clicked on render to mplay, and I'm just doing a 720p, which is fine. And as you can see, the soap is looking better with a smaller scale in the fog noise. It looks like we have some small little bubbles in there, as you can see. And overall it's okay, it's not perfect, but I thought about creating a simple project to show off some of the Houdini capabilities and karmas. So hopefully you have enjoyed this one. Also, I have a Patreon if you want to check it out, where I have also some courses, as you can see, I created in the past. And I also share the project files from all my videos in the channel, so check that out. So yeah, that's basically it. Hopefully you enjoyed this one, and I hope to see you next time. Leave a comment.